Good morning to all. In this video, we will discuss about the 16-bit division program in the 8085 assembly language program. Before that, we should understand what is the meaning of 16-bit hexadecimal number. 16-bit hexadecimal number is nothing but 4-digit number. You can see 4-digit. Example A1FF I have written. It consists of 4 digits. So this 4-digit number, 16-bit number, has to be written in 2 8-bit number, because in 8085 we can handle only the 8-bit data, and we have started storing the numbers from the memory location 4200H, 4201, 4202 and 4203. So two numbers are there, one is the dividend and another one is the divisor. So we have to store in this format. Actually MSB must be stored in the second number. So here A1 should be stored, here FF should be stored. Then only we can use the LHLD instruction. When you are using LHLD 4200, so H will take the MSB, L will take the LSB. So the first address, whatever is stored, will be stored in a L register, and the second number, which is stored in 4201, will be stored in H register. So therefore most significant byte should be loaded on the second memory location. This must be very clear. Similarly here, the divisor has to be stored in 4203. That is MSB has to be stored here. This is 42, and here we should store 36. So we will be convenient to use LHLD instruction to get the first number and second number in this way. In this way means H will take A1, MSB, L will take FF. So the first number is stored in HL register pair, and it is exchanged with the DE register pair, and then again loading the divisor with the HL register pair. So now what we are doing is we are loading BC register pair as 00, and then initializing this quotient actually, and then we are copying the content of L register to accumulator and ORA with H. So the purpose of this is nothing but to see whether the divisor is 0. So when the divisor is 0, we can simply say the answer. The answer is anything divided by 0 is infinity. So in microprocessor we would say it is a something like error, E we are storing, and we store the result. So to check, how to check whether both the numbers are 0 is we store any one of this number into the accumulator. For example, L is stored in the accumulator. L is stored in the accumulator, and it is OR operator with the H register. So only when L and H are 00, then only we get the 0 flag is set. So when the 0 flag is set, now jump no 0 to loop 1. Okay, when the 0 flag is set, it will not be true, so it will go to the next instruction. So now we have got the second number is in HL register pair, that is 36 and 42. So we are copying 36 to the accumulator and ORing with 42. So definitely the 0 flag is not set. We will be getting some value. So therefore jump no 0, there is no 0 now, it will go to loop 1. So in case of 0, we are loading BC register as EEEE, HL register as EEE, and go to jump to loop 2, which means loop 2 we are storing EEE to 4206, that is a result quotient, and similarly 4204 as a remainder, that is also we are moving the BC register into HL register, and then we are storing the same to the 4204. So quotient and remainder becomes EEE. Fine. Now we don't have a 0 here, so jump no 0 loop 1. So loop 1 comes here. Now what we are going to do is we are going to repeatedly subtract. That is called as division program. So since it is a 16-bit number, so we have to perform 16-bit subtraction. Okay, now let us see how the repeated subtraction is performed in 16-bit division. So first, initially we have loaded the first number in HL register pair, that is copied to DE. So the dividend is in DE, and now the divisor is in HL. In this format it is there. So now what we have to do is we have to subtract FF minus 36. So where is FF? FF is loaded in E register and 36 is loaded in L register. So this FF is E, that is copied to accumulator and subtracted with L, sub L. So L is subtracted. So once it is subtracted, it is copied back to the same register. That is the accumulator content is, the result is copied to the same E register. Therefore, we maintain the result in the DE register pair itself. So we are performing the same for D and H. So D and H subtraction is also done. By this time what do we do is subtraction with borrow, because when first time when we are subtracting, if at all any borrow is generated, that is also taken care while subtracting the MSBs of two 16-bit numbers. So after the subtraction, again it is copied to the D register. Now the subtracted result is available in DE register pair. So if you have a simulator, you can verify whether the content of DE register pair is maintained as it is. Now we will, in a calculator, we will verify what is the value of A1 FF I think it's not working. Okay, we will see that. Calculator hexadecimal, that's A1 FF minus 4236. So now the content of DE register is nothing but 5FC9. DE register becomes 5F, that is D becomes 5F and E becomes C9. Okay. Now we will verify the final answer. Therefore, intermediate answer is also needed for us. Now again the HL remains the same, because we are going to repeat the same thing. That is 42 minus. Now what we do is, that is C, that is 5F C9 is going to be subtracted with 4236. So now this subtraction will be performed. This is the second time. So whenever we are subtracting, we are incrementing the quotient once. See this, we have subtracted, no? Subtracted. So jump carry. So when the last, last time when we are subtracting, we may get a carry, isn't it? That is a carry flag. That's nothing but a borrow. When we are subtracting the small number to the big number, then we may get a carry. So now the carry is not generated now. So what will happen? Only when carry, it will go to the loop through. Otherwise, loop 3. Otherwise, it will come to the next instruction. It is incrementing the BC register pair, because the result can be in a 16-bit number. So therefore, we are incrementing the BC register pair. So BC register was initialized as 0 earlier. You can see BC is registered as BC register pair is initialized as 0. Now we are incrementing BC register. Whenever we are performing the subtraction, we are incrementing this and jump loop 1. So we have to complete this iteration until the carry is being generated. Again the same thing is performed. It will keep on be performed. And finally, when the carry is generated, so in 8-bit division also we have done the addition. So one time we have to add. So we just add the last number with this. So we wanted to see what it is. Yes. So what we did is see 5FC9 subtracted with 4236. So now it is 1D 1D93. 1D93. So now again it is subtracted with 4236. 4236 it is subtracted. Okay. So now we can see when we are subtracting 1D93 subtracted with 4236, we get a negative number. See, how do we know whether it is a negative number? Because the carry flag will be generated. Carry flag is generated, therefore a negative number is there. So this one we have to add again. That is plus 4236. So this is the remainder. We will verify the same thing in a simulator and we see that whether this program is working properly. So what we have to get? We have to get the quotient as 2 and the remainder as 1D93. So you will go to the... Okay, before that we will understand how it is adding. So E is added with L, that is E is added with L and B is added with H. So as usual, second time that's a MSB is added, we are adding with carry, and then the added result is stored with HL register pair. Okay, so the results are stored HL register pair, the remainder is there, that is stored in 4206, and BC register pair we have got a quotient that is copied to HL register pair individually, and then that is copied to 4204. So now we will go back to the simulator. Okay, I have a simulator here. So we will type the same number, that is A1FF. So for that what I have to type is, I have to type FF first, FF A1, and then we have to say 4236. So 3642, I have to type reverse, 36H, 42H. Okay, I am just same program, I am just running all at once. So you can see the quotient is 02, only 2 times it is subtracted, and the remainder is 1D93. So our program is working very well. Okay, as usual in a calculator I will tell you how to find out this remainder. So we understand that the quotient is 2. So therefore 4236 multiplied with 2, we get 846C. We just say 846C. So we have to separate this A1FF with this number, which means A1FF is subtracted with this. So we just say A1FF minus 8463. So we get 1D93. See, the same 1D93 is as a remainder. So quotient multiplied by the divisor subtracted from the dividend will give you the remainder. Okay, that's a simple logic. So we are getting the result. So only thing is how to store the number, that is very, very important. So you take the memory address as sequential and store the LSB of the first number first, and then MSB of the first number, and then store the LSB of the second number, and then store the MSB of the second number, and then the result will be stored. Okay, again the result will be like this. So result will be let us say 4205. Okay, so what do we do? So here you can see after addition the added value is stored in 4206. So that is 4206 and 4207. 4206 and 4207. So 4206 means this LSB will be there, that is 93 will be here, and then here we have got 1D. And then the quotient, what is the LSB? Least significant byte is nothing but 0, 2. And then MSB is nothing but 0, 0. Okay, this is the answer. That is okay, whether we have got the result in the same format in the memory location, that also we will verify. We will see that 4207 1D is there, 4207 1D is there, 4206 93 is there, and we can see 4204 2 is there, 4204 2 is there, 4205 0 is there, therefore it is not visible in the simulator. So in this program, the very important thing you should remember is the format of the input number, 16-bit number, the same format in the result also. The quotient and the remainder is also in the same format. That is LSB comes first and then MSB is there. So that is because we are using LHLD and SHLD. Okay, thanks for watching. You may have some doubts, so I recommend you to watch it again for the second time or third time, so that you can understand it better. Even otherwise, if you have some doubts, you can write your questions in the comment box. I will answer all the questions. Thanks for watching.